Step into a modern attic in the dead of winter and you may notice it's bitterly cold, with ice forming under shingles or frost-lining roof timbers. You might assume the temperature is harmless, but in reality, cold roofs are silently killing timber. Unlike decay caused by obvious leaks or flooding, cold and trapped moisture act slowly, allowing rot to develop inside beams and joists over years or decades. Ancient builders, from medieval Europe to Viking Scandinavia, understood this danger instinctively and developed techniques that allowed roof timber to survive centuries in freezing conditions. Today, we're uncovering why cold roofs kill timber slowly and how those old solutions can be applied today. Make sure to subscribe to the channel because this is knowledge that can save your roof from premature failure. The first element to understand is how timber reacts to cold. Cold alone doesn't cause rot, but it exacerbates the effects of trapped moisture. When wood absorbs water from condensation or snow melt, the freezing and thawing cycles expand and contract fibres repeatedly. Over time, this stresses the structure, creates microcracks, and allows fungi to establish themselves. Modern insulated attics often prevent airflow, keeping cold pockets and moisture trapped against the wood. In contrast, ancient builders designed roofs that kept timbers cold but dry, preventing the slow accumulation of decay. One ancient solution was selecting and preparing the right timber. Builders chose slow-grown trees, often felled in winter when sap was at its lowest. This reduced internal sugars that fungi feed on and produce dense, tight-grained wood. Timber was then air-seasoned for extended periods, allowing internal moisture to leave gradually and fibres to stabilize. Today, selecting dense, slow-grown timber and allowing it to acclimate to its environment before installation can significantly reduce susceptibility to slow, cold-induced decay. Roof geometry was, another critical factor in combating cold damage. Steeply pitched roofs, which were pretty common in medieval Europe and Scandinavia, shed snow and rain quickly, preventing moisture from lingering on timber surfaces. Wide overhangs directed water away from walls and joints, and structural beams were arranged to minimize direct contact with accumulated snow or ice. Modern shallow roofs, on the other hand, tend to trap snow, causing slow melting and repeated wetting of timbers. Replicating ancient geometry where possible, steeper slopes, thoughtful beam arrangement and adequate overhangs can really help prevent the conditions that accelerate slow winter decay. Ventilation was perhaps the most powerful tool ancient builders used. Roof cavities were, quite intentionally, left breathable. Air entered at the eaves and exited near the ridge, creating passive airflow that carried away moisture before it could accumulate on cold timbers. So, in modern attics, we often rely on vapour barriers and tight insulation, which, can actually trap humid air right up against the roof beams. This can allow frost or condensation to form. By adding ridge vents, soffit vents, or even just small airflow channels along the timber members, we can sort of replicate this ancient strategy. It helps keep the wood dry while still allowing it to survive those cold temperatures. Surface treatment really complemented these strategies. Ancient builders didn't rely on modern sealants, which, can actually trap moisture. Instead, they applied breathable substances like pine tar, a bit of light charring, or oil-based coatings. These things repelled water, but still allowed vapour to escape. This balance prevented liquid water from penetrating while permitting timbers to release moisture absorbed from ambient humidity. In contemporary construction, using breathable finishes on exposed timbers or structural beams helps us avoid that slow accumulation of moisture, which over time leads to decay in cold environments. Joinery and load distribution were also critical to protecting timber. Beams were connected with interlocking joints, scarf joints, and wooden pegs rather than rigid metal fasteners. These connections allowed slight movement as timber expanded and contracted with freezing and thawing cycles, preventing cracks where moisture could settle. Modern construction often uses rigid screws or nails in engineered panels, concentrating stress and, accelerating damage. Even partial adoption of flexible joint strategies can protect modern timber from slow winter decay. Ancient builders also monitored and maintained timber regularly. In longhouses or halls, roof structures were inspected after storms or seasonal snowmelt, and minor adjustments or repairs were made before problems became severe. Modern homeowners often neglect attics unless leaks are visible, allowing decay to progress unnoticed. Adopting the habit of seasonal inspections, especially after winter, aligns with centuries of proven practice and can dramatically extend roof lifespan. Applying these lessons today doesn't require rebuilding in a medieval style. Start by using dense timber and allowing it to acclimate. Ensure roof slopes and overhangs shed snow efficiently. Incorporate passive ventilation along timber cavities. Protect wood with breathable finishes and use flexible joinery where possible. Finally, inspect regularly for moisture accumulation. These strategies, grounded in ancient wisdom, can prevent the slow, silent destruction that cold roofs inflict on modern timber. If this guide gave you a new perspective on timber survival in cold climates, subscribe to the channel and share this episode with someone who wants to protect their roof from winter decay. Relic Logic exists to uncover ancient construction intelligence that still works today, teaching us how to build stronger, longer-lasting roofs by understanding the principles that kept timber standing for centuries.